A 0.4314 gram sample of pure iron 2 oxalate was dissolved in excess dilute sulfuric acid. When solid iron 2 oxalate dissolved in excess sulfuric acid, the solution contains aqueous Fe2 plus ions and aqueous oxalate ions. As this solid is dissolved in sulfuric acid, this medium is acidic. We will read the question once again. The entire solution was titrated with 0.06 moles per cubic decimeter potassium permanganate solution. The burette reading at the end point is. When this entire solution was titrated with potassium permanganate ions reduced to manganese 2 plus ions. When these permanganate ions reduce to manganese 2 plus ions, both Fe2 plus ions and oxalate ions oxidizes. Fe2 plus ions oxidize to Fe3 plus ions, while oxalate ions oxidize to carbon dioxide. Now we will write the balanced ionic equation for the reaction between iron 2 oxalate and permanganate ions. Oxidation state of iron in iron oxalate is +2. The oxidation state of iron in Fe3 plus is +3. When Fe2 plus ions oxidize to Fe3 plus ions, oxidation state changes from +2 to +3. Therefore, this change involves just one electron. Oxidation state of these carbon atoms in the oxalate ion is +3. During this redox reaction, oxalate ions oxidize to carbon dioxide. One oxalate ion has 2 carbon atoms. Therefore, one oxalate ion produces 2 carbon dioxide molecules. Oxidation state of these carbon atoms in carbon dioxide is +4. Therefore, when balancing this reaction, the first thing is to balance the number of carbon atoms. Oxalate ion has 2 carbon atoms. Therefore, we have to use the coefficient 2 in front of carbon dioxide. Now we will try to find out the number of electrons involved in this oxidation process. The oxidation number of carbon changes from +3 to +4. It involves just one electron. But in this reaction, 2 carbon atoms involved. Therefore, the total number of electrons involved in this process is 2 electrons. That is 1 electron per each carbon atom. Therefore, the total number of electrons involved in this oxidation process is 3 electrons. Oxidation state of manganese in permanganate ion is +7. Oxidation state of manganese in manganese 2 plus ion is +2. The change in oxidation state of manganese is +7 to +2. Therefore, this reduction process involves 5 electrons. Now we will balance the number of electrons. 5 electrons and 3 electrons. 3 electrons multiplied by 5. At the same time, you need to add number 5 to the coefficients. 5 iron 2 oxalate, 5 Fe3 plus ions, then 5 times 2 carbon dioxide. That is 10 carbon dioxide. Then 5 electrons multiplied by 3. At the same time, add the coefficient 3 in front of permanganate ions and manganese 2 plus ions. Next, balance the number of oxygen atoms. 32 oxygen atoms on the left and 20 oxygen atoms on the right. Therefore, we need to add 12 water molecules to the right. Finally, balance the number of hydrogen atoms. There are no hydrogen atoms on the left. Therefore, add 24 H plus ions to the left. This is the balanced ionic equation for the reaction between iron 2 oxalate and permanganate ions. Now we will start the calculation. The mass of iron 2 oxalate was given in the question. Therefore, the first thing we have to do is calculate the number of moles of iron 2 oxalate. Number of moles is mass divided by molar mass. Mass of iron 2 oxalate is 0.4314 grams and the molar mass of iron 2 oxalate is 143.8. The answer is 0.003 moles. Next, calculate the number of moles of permanganate ions. The stoichiometry between iron 2 oxalate and permanganate is 5:3. Therefore, we can calculate the number of moles of permanganate ions. The stoichiometry between iron oxalate and permanganate is 5:3. That means 5 moles of iron 2 oxalate completely reacts with 3 moles of permanganate ions. Now we will calculate the required number of moles of permanganate ions to completely react with 1 mole of iron oxalate. The number of moles of iron oxalate is 0.003 moles. Now we can calculate the number of moles of permanganate ions. That is 3 over 5 times 0.003 moles. The answer is 0.0018 moles. Therefore, the number of moles of permanganate ions is 0.0018 moles. The number of moles of potassium permanganate is the same as the number of moles of permanganate ions. The concentration of potassium permanganate is given. We have calculated the required number of moles of potassium permanganate. Now we can calculate the burette reading, or in other words, the volume of potassium permanganate. Concentration equals number of moles divided by volume. Therefore, volume equals number of moles divided by concentration. Volume of potassium permanganate equals the number of moles is 0.0018 moles. The concentration is 0.060 moles per cubic decimeter. The volume of potassium permanganate is 0.03 cubic decimeters. But the answers were given in cubic centimeters. To convert cubic decimeters into cubic centimeters, we need to multiply this answer by 1000. Therefore, the volume of potassium permanganate or the burette reading is 30 cubic centimeters. The answer is number 3.